Okay, well, let's just dive right in. There's no clicker quizzes on test day. You're having a big old quiz called the test, right? So we don't need no clicker quizzes. So let's just dive right in and start reviewing. So like normal, we'll review for an hour and then we'll test for the other hour. So let's do what we can on this one. So there's going to be 5 questions that don't have A, B, C, D, E answers, right? That are not multiple choice, just like the last exam. We'll do the last 5 or so, 5 or 6 or 4 or 5 or 6. Anyway, here's one. Try number 1 then. Can you do number 1? Notice that no multiple choice, no nothing, to use bad English. Nothing there. Solve that one straight.
I couldn't even get that the way you wrote it out on the answers. I understand what you were doing, where you got to use.
Gotcha.
This right here.
Yeah.
Anytime you see that,
Yeah, it's the opposite. Yeah,
roots and twos are opposite. Catch that in class.
Gotcha. Yeah. So what's the first thing you think when you see this problem?
Power of 2. Break the square root.
Good. I wasn't even thinking about that. Yeah, the root symbol, right? When you see that root, the root symbol, I mean, right away you know you're going to need to do parentheses second power on both sides, huh? I hope that hits you right. Remember, the 2 power and the root are opposites of each other. Is that making sense? So in general, as you look at this test today, anytime you look at number 2, you see another root there, you think, oh, got a 2 power both sides. And then what if you see like a 2 power on something? Well, then you think, oh, got a root both sides. Remember, they're opposites of each other, like a poison and an antidote, right? They're opposites. They neutralize each other, right? If I get poisoned and then I take the antidote, I'm neutral again, right? The poison is eliminated. All right, so that's the first step. Right away you do parenthesis 2 power, parenthesis 2 power. Good? Because you got to do the same thing to both sides. Get balance, right? Okay, take the next step. Oh, yes, and you are going to need to check. That was what Carr said was a good point. I would write check by both these two. When I get the exam today in an hour, I would look through real quick, and any problems that have a root with an equal sign. You got to have both of those things. A root with an, whoop, scribbling here. Root with an equals must be checked at the end, right? Remember, you plug in the answer to the original and see if it's true or false, right? Plug answer into original, see if left equals right. If the left equals the right, it's a keeper. If not, throw it away. It's no solution, right? Remember that whole thing? So there'll only be like 2 of them, So as you look through the exams, when you get it in an hour, they'll probably be at the back, because that's where the ones are that they won't be number 1 and number 2. They'll probably be number 22 and 23 or something. At the back, there'll be a root with an equal. Just write check. Okay. So now how are you doing that first step? I've been giving you a little bit of time. On the this side, it's x squared plus 16. Just square the x, square the 4. No, but I see that all the time. Why is that not right? That's like one of the most common mistakes. That people just think, well, can't you just square the x, square the 4? Yeah, you got it right. You can't do that. You can't. I hope you know. Instead, you've got to write 2 of the whole parentheses, like that. Remember, whenever there's parentheses squared like that, you've got to write 2 of the whole thing, right? Right? Same thing over here. 4 root x plus 1, 4 root x plus 1. That's what the 2 power means, 2 of them, right? We good there so far? Now, on the left side, it's a foil. Right? You know how to do the left side. It's a little foil. Right? So boom and a boom. So x squared plus 4x, boom and a boom, plus 4x plus 16 equals. On the right side, now what am I going to do on the right side? Is the right side of foil also like the 4 is going to go here and then going to go there? No, why not? Why is it so different than the other one? No separator between the 4 and the root. There, it's right up against it, right? It's times. times right there, huh? It's not 4 plus. It's not separated. You don't look at the 4 and the root like they're two separate things and each do their own thing. The 4 separately. No, there's no, whereas over here, the x and the 4 are separated. So they're two separate things, that's the FOIL thing, right? But over here, there's no separation. The 4 is right up against the root. It's one thing. So what happens?
So when 2 go in, 1 comes out.
Good. Excellent. Excellent. Yeah, remember the 2x plus 1's inner root mean 1x plus 1 out. Remember 2 in, 1 out? That's the golden rule of roots, right? That's the most fundamental rule we use for roots. 2 in, 1 out. So 2 for 1 deal with target or whatever, right? 2x plus 1's in roots. That's how you make the jailbreak, right? You gotta have 2 of the same thing in the root. That sends 1 free out of the root, and the root's gone, right? And what about the 4's in the front? What are they gonna do? Just multiply, right? Remember outsiders, remember the story about my father-in-law? Outsiders with outsiders, insiders with insiders. So the 4 is gonna multiply the 4. 4 times 4, 16. And then root x plus 1, the insider with the insider. 1 plain x plus 1, no longer in a root, made the jailbreak. See that step? See how the left side's a FOIL because they're two separate things, and the right side's just outsider times outsider, 4 times 4, insider times insider. And 2 insiders ship 1 out, don't they? We good with that step? That from here you can probably get it. That's the hardest step. Is everybody okay with that step? I would be more than glad to talk more about it. Anything else I can clarify on that? Yeah.
I know you said that this isn't like multiple choice, but do you like, say if we got like half of it right, do you get partial credit?
Yeah. So that's the advantage of the non-multiple choice, is there can be some partial credit. Yeah. So yeah, so do what you can. Yeah, you might get some partial credit. Even if you get stuck 2/3 of the way through, you might get some partial credit. Okay, so then 4x and 4x is 8x. Over here, boom and a boom, it'll distribute. And you get 16x plus 16. We good to there? Good. Just gathered some like terms over there on the left. Everybody really okay with that root step, right? Outsiders with outsiders, insiders with insiders, right? Right, I told you my father-in-law played football for Sac State against Folsom Prison. I thought he was an insider for a minute because he lost his team, right? So you break the rest. Outsiders, it's a big deal. At that moment, it was a big deal to Dad that he was an outsider and not an insider, right? Outsiders interact with outsiders. Insiders with insiders, right? 4 times 4. And root x plus 1, root x plus 1. And 2 in, make 1 out. Okay. So now at this point, everybody good to hear? There's certain things that really have to jump off the page for you. Not a lot of them, maybe 2 or 3 big things. Like one of them we already did with the root. When you see a root symbol, you got to think, oh, 2 power, parentheses, 2 power it. Right? That's just got to be knee-jerk reaction when the dock hits your knee and your knee just shoots. Your leg just shoots. It's got to be that way. When you see a root on this test today, a root, then you got to go 2 power. 2 power. That's just got to be automatic. That's just always what we do when we have a root with an equals. Okay, another thing that's got to be automatic for you is this x squared. You just got to know right what to do. There's going to be a bunch of these. We've had them before. They'll be on the final. What do we do when we see x squared? Get a 0, factor. Right? Remember that? When you see x squared, I'll scribble it somewhere. I don't know where. I'm going to erase this. I don't have room for this anymore. When you see x squared, you have got to know x squared with an equal sign, You've got to, number 1, get a 0 on one side, the opposite side from x squared, and then do the factor thing, with the 2 parentheses. So you got to go over here and go, okay, I see that x squared. So here, x squared's over here on the left. So you make the opposite side from x squared 0. So I got to make this side become a big egg. Everybody with me on that? The opposite side from x squared, we have to make that 0. So how am I going to make that 0? Yeah, just do the opposite of everybody, huh? Boom, boom. And whatever you do to one side of the wall, no choice but to keep the balance. Do the same thing to the other side, exactly. Like that, good so far? So that one's got to be just automatic for you. Because it's going to come up a lot. So when you see x squared, put it on your 3 by 5 card. Put this whole thing on your 3 by 5 card. You haven't got that made, now is the last chance. James.
I see where it's put this equal to 0. It's still 0.
Everybody okay? Making sense? So put this to 93. This is a good one to have in your card. This one has almost everything in it. So what do we got then? X squared minus 8x equals 0. And these guys just canceled, huh? And this cancel.
Yeah.
Good so far? Right, so when you see x squared, put this on your 3 by 5 card. When you see x squared, get a 0 factor. Here, I could write root. If you see root with an equal sign, step 1, 2 power both sides. Step 2, check at the end, right? So when you see a, well, actually, you know what? I'm skipping a step. Let me fix that a little bit. Step 1, get the root alone. Really, is step 1, and then 2 power both sides, and then step 3, check at the end. So those are the 3 steps for the root ones. Get the root alone, 2 power both sides, and check at the end. So you just want to know that whenever you see a root with an equal sign. Root with there are some roots without equal signs. We'll see those too. And then x squared with an equal sign. Get a 0 factor, right? Just want to know those, Cole. Put those on your 3 by 5 card right now if you don't. All right, so I got my 0. Now I'm supposed to factor over here. How do I factor that? What do I do?
You gotta take an X out.
Yeah, it's take out an x. Everybody see it's not 2 parentheses. Why isn't it like 2 parentheses? Isn't that how we usually factor?
Could have 2 terms.
Because the third term disappeared.
Yeah.
If this hadn't canceled, there was like a 6 here or something, then I would do the 2 parentheses, right? If you have 3 things, that's when you do the 2 parentheses, right? But if you just have 2 things, just take out what's in
That
common.
was my question up there, how come you didn't do it up there on X squared plus?
Right here, didn't have my 0 yet.
Okay.
Good question. Yeah, first, that's why the order matters. Number 1, get the 0 first. Then think about factoring. Good question, James. Yeah, everybody see that? Why I didn't factor up here? Because I didn't have 0 yet. So it's first get a 0. When you see x squared, you got to think get a 0. That's your first step on the opposite side from x squared. All right, so I'm to here now. What do I do now?
Check.
Well, I don't have answers yet. I need my 2 answers, then I'll check. What are my 2 answers?
0 and 8.
Yeah, does everybody see that? Remember you said each one to their own separate 0? Remember that?
Yeah.
So x alone is 0, or x minus 8 is 0, right? Because if you multiply 2 things and it comes out 0, that's what this is saying. Something, an x alone, times something else, an x minus 8, is equaling 0. If you're timesing 2 things and it's equaling 0, either one can be 0 to multiply them, and the answer come out 0, right? So, and then this one, you remember you just move the minus 8 to the other side, it ends up being plus 8. Remember, it's opposite sign. So the 2 answers are 0 and plus 8, maybe.
Then you check.
Maybe. We got to check them, don't we? We've got to check them to see if they're right. Right? So let me come up here. I'm going to erase that. I hope you got it down if you needed it. And I'm going to check it now.
On the test, do you have to check it?
In the end, you just have to show me the right answers. So if you show me the answers, like if you just leave it like this on your paper, and really, whoop, I'm the wrong thing. If you just leave 0 and 8, and one of them's not actually right, then you'll lose some points. Yeah, so if you give me false answers, so now are they actually both right? I think they are, huh?
Yeah.
So actually you could just leave it on this one, you'd be fine. But sometimes one of them's bad, as we've seen, huh? So sometimes one of them's bad. So let's check them. Check x equals 0. So how do we check? Remember, you always check with the original. And you can just use your calculator. You with me? So there's the original. Whenever you check, you just write down the original and plug in the number, the answer that you got. So that's 0 plus 4. That's 4 times, and just use your calculator. You don't need to do any algebra manipulation or anything. The check should be pretty easy. Just hit the buttons for the left side, hit the buttons for the right side, and see if they're equal. It's supposed to bring equality, isn't it? That's what a real answer does, is makes it true, makes it equal. A false answer makes it not equal. Make sense? So what do we get? 4 equals 4. If you work it out, it's 4 equals 4. Because this is square root of 1, and root of 1 is just 1, and 4 times 1 is just 4. So yes. So 0 is a keeper. 0 is a valid answer. And how about let's check x is 8. Where do you check it? Again, the original. Always the original. So you start again with the original. Plug in the 8. Plug in the 8. What is that? 8 plus 4. 8 plus 4 is 4 root of 8 plus 1. Is that okay? I just plugged in 8 for x everywhere. What do you get? Use your calculator. Left side 12. Right side 4 root of 9, which is 4 times 3, which is 12. 12 equals 12. Yes. They're both yes. So they're both good, so we keep both answers. 0 and 8 are both valid answers. Usually one of them doesn't check, huh? Say the 8 didn't check, then I would just cross it off, and the answer would only be the 0. Good? Better move on. We got a lot of other problems. That was a long one. Questions on that? Want to try that second one? You can see it. I want to leave this up for those who need to copy down. So go ahead and try number 2. That should be a little easier. Same thing, a little bit easier. Second power both sides there. Right? When we see that root, second power.
On the test, do we put 0, 8?
Yeah, I don't care. You can just leave it like it is, 0, 8 on your paper. Yeah, 0, 8, you're right, is technically the answer. Correct. So try number 2. Try number 2. 2 power both sides again, right? So parenthesis 2 power, parenthesis 2 power. What does the 2 power do on a root? Cancels it. Poison, antidote. Neutralize each other, right? I go to a fresh screen. Okay, so number 2. I'm going to right away go 2 power, right? And that's y squared on the left. On the right, the root cancels the square, and it's just 2y plus 8. I don't actually square anything. Why not? The root canceled the square. Just like if I got a poison in me, and the doctor gives me the antidote. The poison doesn't kill me. The antidote neutralizes the poison. The 2 power neutralized the root, didn't it? They canceled each other out, so nothing's happening on the right side. Good to there? That's the main, it's one of the main themes of this test. 2 powers and roots are opposites.
I'm so confused now, because on the first problem, how come we didn't take away those to the first problem? How come we didn't?
Yeah, so the first problem, what was the first problem? The first problem, yeah, see right here? This 2 power eliminated that root, and it became a regular x plus 1.
Oh, so it did?
And it did. And it squared the 4 to be 16.
Oh, okay.
See that? It's the same thing. See what it did? Now, I showed it a different way with writing 2 of them, but it's the same effect in the end. There's just 2 ways to arrive at the same conclusion. 2 ways to say it. Same result. See how the root was removed? No, and the 4, now why did the 4 get squared? Because he wasn't under a root. He wasn't protected, was he? Right? The poison hit him. Right? 4 got squared to be 16. But the x and the 1 did not get. Why didn't I write x squared? Because the root protected it. Right? And it canceled. See that? Makes sense? We good with that? So roots cancel squares, or squares cancel roots. All right, now we see y squared. That's got to be automatic knee-jerk reaction. What do you do when you see y squared?
Get a 0.
Get a 0. It's got to be your first thing. Get a 0. So what do I mean, get a 0? Make this other side, y squared's on the left side, make the other side become 0, huh? So how do I make the other side become 0? Just do the opposite. Minus 2y minus 8, huh? That will make them go away, and you'll have 0. Right? But whatever you do to one side, you have no choice but to do the same thing to the other to keep the balance, right? So let me bring it over here. So what do I got? Y squared minus 2y minus 8 is 0. Is that good to there? Everybody making sense out of that? Or you could have just grabbed these guys and jumped them to the other side, and they just change signs. They both become negative, huh? Same thing. I've said it 2 different ways. Whichever way is easier for you to do is fine. But the main thing is get a 0. You good with that? When you see x squared or y squared with an equal sign, get a 0. Right? Get a 0. Now what?
Two parentheses.
2 parentheses, y and y. What multiplies to be 8? Adds, what times what is 8?
-4 and
Yeah, 4 times 2 is 8, huh? How do the signs always go? Sign in the middle, sign on the bigger. 4 is bigger than 2. Right? -4 plus 2 will make -2 in the middle. Remember, sign in the middle. Sign in the middle here always goes on the bigger. 4 is the bigger than 2. Sign in the middle goes on the bigger. And then, you know, it just ends up being opposite sign and opposite sign when you go from parentheses to answer, right? So +4 and -2, maybe. Maybe. We have to check, huh? So let's check the +4 first off. How do we do? We go back to the original. There's the original, and you plug in the 4. Plug in the 4. 4 equals square root of 2 times 4 plus 8. 4 equals, what is that, root of 16. 4 equals 4, yes. That one worked. Question, James.
How do you go from -4 and +2 to the opposite?
Yeah, because you set each one to 0. I skipped that step. You set each one to 0. Remember, when two things are multiplying to be 0, if two things times to be 0, either one could be 0. Right? If I said, hey, I'm thinking of two numbers, they multiply to be 0. Either one of my numbers could be 0 to make that happen. Then how do you solve this? This jumps to the other side and changes signs. Jumps to the other side and changes signs. So the 4 is the keeper. How about the -2? If you plug in the -2, it's not going to work. So, so -4 plus 8. -2 is root of 4. -2 is 2? No. So throw away the -2. The answer is only the 4. Just the 4. That's usually what happens. One's good, one's bad.
Does the negative always work?
Yeah, it's not that simple, or I would have told you. Yeah, often. But sometimes it could be that the negative is the keeper and the positive is the bad. But usually, you're right. Usually the negative's the throwaway. Kind of expect that, but they could make one tricky that does the other thing. But yeah, usually the negative's the tosser.
Is this
Yeah.
following kind of the structure of the test we're going to take? Like the first two are going to be.
No, these will be at the back, actually. Yeah, it's reverse. These are at the back because these will be the non-multiple choice ones, which are going to be the last 4 or 5 or 6 problems. All right, we good with those? Those are two of the hardest, though. I want to do those right away. All right, you want to try number 3 there? Can't even see number 3, huh? So I'm gonna give us a fresh screen for number 3 here. Let's do it. Number 3. Try that one. Can you see it? Kind of small. I'm gonna bring it up here. So number 3, square root of 108x over the square root of 3x. All right, try that. We're back to multiple choice now. Give that a try. You guys have your calculators? 3x5 card. Put on your 3x5 card. Whatever you need right now as we're going if you don't have it. May your 3x5 card be as awesome as Car's 3x5 card. Of course, that wouldn't work for me because I would need some kind of magnifying glass to be able to see that stuff. All right, we good? What do we do? Give you another second because I want you to remember it rather than you just do it. You know what to do? Give you 15 more seconds.
Are we, in this particular one, are we going to multiply by the square root of 3x first?
Good question. Answer's no. Okay, let me help. That's why I want to help. Because that's the natural. We do that so often, don't we? Right? But remember, it's important to divide first when you can. And to hold on to all your calculator parts while you're divide first. It'll be so much easier. Even though what you're saying is true, it's not illegal or anything, this will be way easier. So just take your calculator, take 108 and divide by 3. 36, right?
Yeah.
It's going to be 36, okay? And the x's cancel. You see, you can divide them because they're both insiders. All right, did you hear that? Did it register with you?
Yes.
Meaning, if this was a regular 3x, not in a root, I would not be allowed to divide because that would be insiders trying to interact with outsiders. If you're in prison, you socialize with prisoners. If you're not in prison, you socialize with not prisoners. There's no crossing the line. Same thing with roots, right? If you're an insider, you interact with insiders. If you're an outsider, you interact with outsiders, right? So it would not be allowed in this case, but since they're both insiders, sure. Just divide them. Way easier. Just divide them. The x's will cancel, just like they always would in any other situation in a fraction. And the numbers divide, and you get root of 36, and what's that? And we're done. That easy. That quick. Make sense? So remember to divide today. Been waiting for that one, huh? All right, we good? Can I flash to a new screen? Put that down. Oh, you could. It's not wrong or anything. It's totally right. You're totally right. You can make it one big old like that. But then I would still just cancel and divide, and then I would still just end up here. So I'm saying, why? Let's just skip that step and just go straight to this.
Okay.
So it's not wrong or anything. It's just an extra step, not required.
Okay, it's, skip the class, so it's probably.
Yeah, both are right. You can make it one big old, you're totally right. One big old root or two separate is good either way. All right, where are we at? Number, oh, I lost my spot. Where was I? What did I do? Oh. Is it this one? Yeah, good. There it is. I got it again. Okay, number 4. Try, no, 4 is easy. We don't got time for number 4. Do we? Yeah, do 4? What do you do with 4? So you take that 24 and you break it down, right? 4 times 6, 2, 2, 2, 3. Or if you get Casio Natural Display, you just hit the button on your calculator, right? So it's 2, 2, 2, 3. And x squared y is x, x, y, right? So I just broke it all apart. What's the golden rule for breaking the jail? The square roots, 2 in, 1 out. 2 2's in, 1 2 out. They're both gone, right? 2x is in, 1x out. They're both gone. It's the golden rule for breaking out of jail, right? 2 in, 1 out. So we get 2x on the outside. What's left on the inside? 2 times 3, 6, and y. Good? That one's easy, right? All right. Look at number 5. That's not an easy one. Number 5, graphing. Yeah, you got to get the slope for both. You got to get the... Yeah. So try number 5. Number 5, you got to get both those y's alone, right? You good there? So let me let you be off and running. So number 5, get y alone in the first equation, get y alone in the second equation, and then graph both lines on the axis system. You're looking for where they intersect. Can I go to fresh? Okay, so you take the first equation, 4x plus y is negative 2. And you got to get y alone, so grab the 4x and jump it over. Negative 4x minus 2. Is that good? Y's alone? Right, when things jump to the other side of the equal sign, they change signs, right? So how do we graph that thing now? Where do we start? Where's our first dot? Yeah, start at the negative 2, huh? Start down 2 in the middle, huh? So right there at negative 2. Everybody see where I'm putting that dot? It's always on the middle line, huh? So I went down to negative 2. I'm putting a dot right there at down 2. That's my first dot. Remember how to graph? Your first dot is that number off to the right. It's always on the middle. If that was a +2, I'd go up 2 in the middle. If it was a minus, it is a -2, so I go down 2 in the middle. Now, how do I get from this first dot to my second dot?
Down 4 over.
Yeah, you take the slope and you put it over 1, and that's rise over run, which means down 4. So down, I don't know if I can do it very well. 1, 2, 3, 4 over 1. So right there, down 4 over 1. That good? Down 4 over 1. From the first dot, down 4 over 1 to the second dot. And then just connect the two dots, right? Let's connect them. So there's the first line. We good with all that? Now let's do the second one. So what are we supposed to do with the second one?
Get Y alone.
Same thing, get y alone.
Subtract X plus one.
So move the x over, becomes a negative x on the other side. Put it in the front, we just put the x stuff in the front. So the right side will be negative x plus 22.
And then divide everything by 4.
What's that?
Divide everything by 4.
Right. We good to there? So I jumped out x to the other side of the equal sign. Becomes a negative x. Keep it in the front here. And then finish solving for y by divide everything by 4 is correct. So y equals minus x over 4 plus, now 22 over 4, just use your calculator. 5.5?
Yeah,
5.5? Just divide on your calculator. Because I don't want a fraction there. Right? I want a fraction in the middle, because that'll be my slope, but I do not want a fraction on the right. So just make it a decimal. Don't leave it a fraction. Remember, because I just want, this is my starting point. It's not a rise and a run, huh?
That's your Y there.
Yeah, that's your starting point, right? Up 5.5 in the middle. I don't want a fraction there. Does that make sense? You want fractions in the middle, but you don't want fractions at the backside. So just divide that thing, get a decimal. It's good we saw this. This might be on the test. I don't even know. But this gives people trouble a lot. Does that make sense? You don't want fractions at the back. Divide them on your calculator, get a decimal. All right, so where's the first dot?
0, 5.5.
Yeah, 5.5, right there. Looks like 5.5 up in the middle, right? See up here in the black? Right there, doing my starting dot. Up 5.5 in the middle. So there, I'm on the graph. I'm taking this now and putting it on the graph. So I'm up 5.5 in the middle. Right, that's what this says. Go up 5.5 in the middle. So that's your starting dot. Now, how do I go from my starting dot to my second dot?
down 1 over 1.
Yeah, because there's no number on the top, so just put a 1, huh? Yeah, rise and run, down 1 over 4, huh? So down 1 over 4, just do the best you can. I can't tell. I can't mark the thing up. It's about like there. I'm not real picky on your graph as long as it's generally in the vicinity. I can tell you know what you're doing. Connect the dots, right? That's down 1 over 4. So where do they meet?
Negative 2 and 0.
It's hard to tell, isn't it?
Oh,
It's really hard to
-2
tell.
and 6. Negative 2 and 6.
Yeah, negative 2?
And 6.
8, 5.
Okay. They intersect at negative 2, 6. Doesn't look like it on my graph. Negative 2, 6. Back, it looks like back 5 or something on my graph. You know? That's why graphing is such a lousy method for solving things. Now, don't worry about this a lot. It's 5 points. All the problems here are 5, but 20 questions. 5 each is 100, right? So 20 questions. Every problem is 5 points. Every problem is half a grade. I'll give you 4 out of 5 if you got it's 2 points for each graph. So if you have this and then you can't find that last dot, it's only 1 point. Don't even worry about it. Move on with the rest of the test. Just leave the graph. So what do you know right away? This one won't be multiple choice. This is one of the back 5. This also is one of the back 5, not multiple choice. So in other words, I'll give you 2 points for each line done correctly. So you get 2 and 2 is 4. 1 point for finding the actual -2.6 final answer. That's only worth 1 point.
Is there only one of those?
So if you can't tell, there's only one of those. Oh, no, there might be 2. Yeah, there's 2 on the practice. There might be 2. So, so if you can't find it, don't worry. How could you find it if you really had the time and you wanted to find it without graphing? You could do the addition method. No, you could just say, look, I'm just going to solve it the other way we learned. You go back to the beginning. Right, I'm just going to do this quick. It's only 1 point. You could just say, oh, I'm going to do it the other way. Remember where you make the fronts opposites? Make this guy -4x, and then add them. Just do it that way. Yeah, that whole thing. And then you could get the answer without using a graph. Yeah. Yeah, so I'm not going to take time to do that. Let's do the second one here, guys. This one. Try that one. That one's worth our time. Yeah, there's probably 2 of these. There's probably 2 graphs on the test today. So try that one. So that means, when I say try, it means solve for y. Get y alone in both equations. How we doing? How do you take x equals -y and get y alone? Does that seem weird?
No, it's gonna, I think it's gonna be, end up being y equals -1/1 x plus 0.
True. Yeah. So I got to get rid of that negative sign. Can't have a negative sign, right? That negative sign means -1, really. Can't have it. Y needs to be alone. Nothing in front of y. No negative sign, no nothing. To use bad English. So, got to get rid of that negative sign. So what do? Well, you divide, right? Or multiply. It's gone. Right? That's what we do when we got something in front of y, I want to get rid of it, right? Now, this is a little weird. X over -1, that might look weird. Couple things. First off, move that negative sign to the top. You don't have to, but I think it's be easier for you. Right? Remember, we've seen that before, right? That's not new. Minus sign in a fraction, doesn't matter where it's at. Bottom, top, front, whatever, it's all the same thing, right? So just move it to the top because that's more what we're used to. And where's the number off to the right, right? Aren't we supposed to have, right, look at this one. Aren't we supposed to have like an X thing and then a number off to the right? So here's my X thing. Where's my number off to the right? It's not there. I don't have any number off to the right. So put a +0. Because that's the same thing. Adding 0 is the same as nothing. Right? Am I confusing you? Let me hold up there for a minute. So everybody see it's a little bit of trickery there. Yeah, so I divide, I had to get rid of this minus sign in front of y. Whenever we have anything in front of y, we divide by, like the 4 up here, right? I had the 4y divided by 4, right? So whenever you have a number in front of y, you divide. So I got a number in front of y, I divide. Okay? And then I just took that minus and I moved it to the top instead of the bottom. Does that make sense? Now, good. Remember, we learned previously that you can move minus signs in fractions, right? Bottom, top, doesn't matter. Okay, and then I needed a number. I had nothing off to the right to just make that 0. Because we need a number. Why do we need a number? Because that's where I start on the graph, huh? Right? That number, like on the last one, the number off to the right is my starting dot. It's my first dot on the graph. We good? How are we doing? I can't read your guys' face. You're just giving me nothing. Just shake, say, this is terrible. I don't understand this at all. Or say, okay, I'm okay. Is this making sense? Do you want me to keep talking about this? We good? Anything I can say to help if it's not making sense? Is that good?
So the starting point was going to be
0. Right. So the starting point is 0. Start at 0, right? And then where do we go from 0?
1 down.
Yeah, because there's really a -1 up here. So rise over run. So it's down 1 over 1, huh? So right there. Does that make sense? Down 1 over 1. Connect the dots. It's a diagonal line. Is that good for the first one? A lot of people get thrown off by that. Does that make sense? See what I did? Again, I have the minus. Whenever you have a minus next to y, you got to divide both sides by minus to get rid of that, to make regular y, huh? And then the minus from the bottom, you can always move to the top. And then nothing to the right is 0. Okay, now how about the other one? The second equation right here. What is that? Y plus x equals 6?
Jump to the other side, make it negative.
Yeah. So to jump that x, right. So negative x plus 6. Beautiful. All right. Yeah, put it over 1. Ready to graph. Where do I start? 6. That's right in the middle. It's up 6. Right up there. Up 6 right on the middle line. And then down 1 over 1, right? Down 1 over 1 like that. Connect the dots. There we go. That good? Where do those two lines intersect? They don't. No solution. This one has no solution because there's no intersection. Right? The answer is where they intersect. Those two don't intersect. No solution.
They're parallel lines.
They're parallel lines. We good on those graphers? Questions? Yeah.
No solution in the answer.
Yeah, no solution. Yep, the answer is no solution. Because there's no intersection, right?
So when they're parallel, there's never going to be any solution to the intersection.
Right. Because the answer is where they intersect, and they don't intersect. So there's no answer. Is that good on the graphers? We good? So you got to get y alone on the graphers, right? Get y alone. We better keep moving. All right, number 12, word problem mixture. All right. So on the mixture, what setup do we use for the mixture? The beakers, the 3 buckets. Remember those? Bucket number 1 plus bucket number 2 equals bucket number 3.
These are easier. I think you do number 7.
What was that one? I'll come by and look maybe. All right, so we got the buckets. On the bottom go the percentages, and the top go the amounts. So put the 3 percentages on the bottom. 12%, 10%, 18%. That's wrong. What if I told you guys? Now, math, you want to be as real as you possibly can. What if I said, hey, I was mixing some stuff, and I mixed some 10% acid solution. I tried pouring some. I got some real bad gum on the bottom of one of my shoes. I tried everything to get it off. So I tried pouring. I've got some pool acid out of it. So I tried to pour muriatic acid, it's pool acid, on my shoe, and it was smoking, but it wouldn't come off. Then I ended up sanding. I just grabbed a sander to sand that worked. But anyway, that red ice, yeah, I tried, and it was really in there. Anyway, sanding worked great. I just sanded a little bit of rubber off, and it was gone. But the acid didn't work.
We've got to get to the dirt problems.
And now the top of the shoe is a little discolored because of the acid. My wife is not impressed with my techniques. So I said, hey, maybe you should call me. All right, anyway, I'm getting off topic. So if I said, hey, I mixed some 10% stuff and with some 16% stuff, and it came out 18%. No. When you mix, it becomes between them. The stronger and the weaker become between. The final product, the result, the stronger and the weaker mix between them, right? You can't make it stronger, right? If it's 10% acid and 16% acid, the final product's going to be between them. It's not going to be more acid. Where'd that come from? Right? You with me? Does that make sense? The final one, whenever you mix two things, you're getting a mix. You're getting something between them, right? So the final percentage can't be the 18. It's got to be, so what are the 3 percentages we're looking at? 12%, 10%, and 18. The one on the end, the final product that the other two may equal, the mix, the final result that we're trying to make, it's got to be the mid-level. It's got to be. The stronger and the weaker combine to make the final thing be the mid-level. So which of these three numbers is the middle one? 12%. He's in the middle. He's between 10 and 18, isn't he? 12 is in the middle. This one's got to be the 12. Does that make sense? That's got to be the 12. Is that good? Are we happy? So then the other two, the order doesn't matter at all. Thanks, Seth. The other two, 10%, 18%, it doesn't matter, right? Or 18, 10, whatever order on the other two. Does that make sense? The one on the end, the middle level, goes there. Something stronger and something weaker combine to be a final product between them when you mix things. Okay, so watch out, they're trying to trick you. So you can't always just take them in the order they are in the little story problem. You have to know that when you mix things, the final one is the mid-level. The final thing, the stronger and the weaker, the weaker brings the stronger down, the stronger brings the weaker up, and the final thing is between them. Okay, now, what else? Is there any other numbers they're giving me?
96.
Where is that? I don't even see it. Oh, there it is. 96 ounces of the desired alloy. What's that? Well, that goes in the end. It's what we desire to make. So what goes in the other two spots?
X plus Y.
X and Y. Yeah, remember these? There's always X and Y in those first two spots. Okay, now I have two letters. What does that mean I need?
Cancel.
Two equations.
Oh, two equations.
If you have two letters, you've got to get two equations. Now, I don't have any equations. I just got a picture right now. Where's my equations? What are my equations? Well, the first one's right across the top, right? X plus Y is 96. That's the first one, right across the top. What's my second equation?
10x plus 18.
Can I just do the bottom? No, those are just numbers. I can't do just the bottom. I would only have numbers. So what do? You use the whole thing, whole thing, whole thing. You multiply, right? So the first equation is the tops. The second equation is you multiply 10 times x, 18 times y, and 96 times 12. Somebody have a number on that? 1150. 1152? Thank you. 1152. Is that good? On that. So if you don't have this on your 3x5 card, now would be a golden opportunity. Put this one on your 3x5 card. So the first equation is top, top, top. Second equation is multiply, multiply, multiply. Top and bottom, top and bottom, top and bottom. Good to there. Now I've got two equations with two letters. What am I going to do? How do you solve two equations with two letters? You have a bunch of these today.
Cancel.
Yeah, make these fronts opposites, right? You with me? We always make the fronts become opposites. So I'm going to multiply the top equation, by negative 10, negative 10, negative 10. Everybody see what I'm doing there? I did negative 10, negative 10, negative 10 across the top equation. Why? Because I want to make these fronts become opposites. So that'll become negative 10x minus 10y, and that'll be what? Minus 960? The second equation hasn't changed. Just bring it down. Now we add them up. Am I going too quick? Does that make sense there? Is that making good sense? So again, on the mixture problems, you put the mid-level percentage on the right, and then x and y on the left. Your first equation is top, top, top. Second equation is multiply, multiply, multiply. And then you got to make the fronts become opposites. So I did negative 10 on the top square. These are opposites. So that when I add them, those will cancel, and I get what? 8y, and this is 192, right? Things I can answer to that point?
24 ounces of 18%.
No, questions, I mean? Did anybody have questions? Is that making sense? We're not quite done to divide by the 8. So y is, what is it, 24?
Yeah.
24? Y is 24. Do,
96 minus 24 is 72.
is that good so far? Once we get y, how do we get the other one?
Take 24 and put it for y at the top.
Yeah, so you take the x plus y is 96, that top equation, plug in the 24. X plus 24 is 96, subtract the 24. And x is something, what is it, 72?
Yeah.
X is 72. So we got it. Questions on that one? Careful, what if it's a multiple choice test? I mean, what if it's a multiple choice problem? Which answer do they want? How do you know if they want X or if they want Y? How do you know? Look at what they say. Look at the how. Here comes the question with the word how. How many ounces of 10%? See it right there? They want to know how much 10%. So is that X or is that Y? Look at the 10% beaker. Who did I put with 10%? X. They want X. In the end, really all they want is X on this one. But they just as well could have asked for Y. Does that make sense? Look back for the question. Questions on that one? Is that okay? Did you get that down in your 3x5 card? Question, Martha? Well, I'll come by. Any other general questions on this one? That good? All right, try that one. Nickels and dimes, quarters and nickels. Total of 22.
Yeah, that's another method. That works too. Yeah.
Good. Yeah, that's fine.
So Q plus N equals 42. Quarter is 25 cents. And equals 0.5.
Okay, show me how you do this that other way. Yeah.
Quarters and equals.
Yes, yeah, right. Yeah, okay, well, we got one. Yeah, that works. That's another way that's okay. Yeah.
All right, how are we doing? We getting this one? So it's a money problem. What do we do on money problems? Remember, you have one equation that is no money and the second that's all money. Remember that? Got to separate the money from the no money. So the first one is no money at all. So you just go quarters plus nickels is 22. That has no money in it. And then the second one, you put in the money. 0.25 times however many quarters plus 0.05 times however many nickels is $4.30. Does that make sense? Notice right here, no multiply. People get it confused with the mixture ones, and they try to multiply this times 22, but that's not right. It's not saying $4.30 22 times, is it? It's saying the total amount of money is $4.30, period. Right? Does that make sense on that? So write that in your 3x5 card. There'll be a money problem on the test today.
It's XY equals.
If you want to do XY, I think it's easier to use meaningful letters, but
Do the opposite.
yeah. So how am I going to solve for this now? What am I going to do now? I've got my two equations with two letters.
-25Q.
Yeah. Are you guys getting the hang of this?
And
Yeah.
-0.25 times 22.
-0.25, -0.25, -0.25. Is that good? We're going to multiply, multiply, multiply. Again, because I'm making the fronts become opposites, huh? Everybody okay with that? So minus 0.25Q, minus 0.25N. So it'll be minus, is it 5.5? And the bottom one is that. Add them up, cancels. Minus 0.20N is minus 1.2. Divide by minus 0.20. N equals a 6. So it's 6. Question?
Can I did it by -20 and negative delta 1.20.
Yeah, sure. Did you divide in your calculator?
36.
We good there? So N is 6. And then how do you get quarters? Well, there's 22 coins altogether. Yeah, 22 minus 6, what is that? 14, no, 16. 16 quarters, 6 nickels. How are we doing on that? Is that okay? Are we good? So we got the mixture, we got the money. Got both those on your 3x5 card, I hope. We really got to take this test. We can't fool around much longer. I wish we could review some more root ones and stuff, but we're kind of out of time. All right, so we better move to our test. So we got an hour. See you, James. Thanks. Straight back, please. Oh, there's one more. Straight back, please. Oh, that one doesn't work. Did you ask around? Anybody have an extra scan code? Yeah. Yeah, it's there. It's waiting for you.
Straight to the back.
This is
5/3? I don't remember shit.